The title of our presentation today is 20% Uplift in Production Experience Using High Transport Proppant Technology. This presentation demonstrates our Carboair technology. Hello, my name is Brian Davidson. I'm here with Lee Reynaud, the product champion for Carboair. Lee started his career with Schlumberger after graduating from Texas Tech with a degree in petroleum engineering. He's worked for different operators as well as a consultant, has over 20 years of experience in the oil field. This webinar is being recorded, so if you have problems seeing it or hearing it, it will be available afterwards. And we also ask that you submit some questions. We will answer a few of them at the end of the presentation. Now I'd like to turn it over to Lee to make the presentation.
Hey, good morning, good evening, everybody. Thank you, Brian. Welcome to webinar on Carboair. So before we begin, I want to discuss a few keywords that you'll be hearing throughout this presentation. Obviously, Carboair. You will hear ultra lightweight ceramic, 2.0 specific gravity, greater contact area, lower settling velocity. We will also mention it is lighter than sand. We will discuss some slot flow videos as well as the results, some production results from some fracs, and review one exciting and high-risk gravel pack. We will also discuss how and why it's made. Speaking of how and why it's made, we were facing an industry problem. Operators were approaching Carbo saying, what can we do to extend the length, the height in our frac? We're increasing sand, we're increasing water to great proportion. So what can we do? Are we getting the true frac length? Are we getting the height? So the Carboair said, we agree with these. So what we're going to do is we developed Carboair. It's a ceramic proppant, engineered internal porosity. It has a 2.0 specific gravity, lower density, which ultimately increases contact area, length, and height. It's obviously durable, and the end result is we've increased productivity. So what does all this information mean? Well, it means improved physical properties. We've made a lower specific gravity and bulk density proppant, lighter than sand, over 40% lighter than intermediate density ceramic. The chart on the right, you'll see the key figures for the Carboair, sand, and intermediate density ceramic proppant. One of our keywords we like to say is better shape than sand. So what does that mean? Natural sand has an angular tendency, so it packs tighter. That does not necessarily mean more length, more width. What it means is the roundness of a ceramic proppant has a looser packing, resulting in higher volume inside your fracture, utilizing the same pounds. I will show you these later on in this slideshow. Now, what can we do with this awesome proppant? Well, obviously it was a slickwater fracturing environment. That was the main thing. We want to extend our frac lengths. We need more coverage. So we said, great, slickwater fracking is the key. How do we achieve this? So we thought, well, we can tail in like a typical ceramic. We can also lead in with it. We looked at other ways of using it, alternating stages, layering it in, alternating sand, alternating air. Beyond the fracturing world, we had to look at gravel packs, horizontal well bores, extended reach, wells with high angle trajectories, wells utilizing higher pump rates, higher pressures. We can lower these utilizing Carboair, a lightweight ceramic. So why does it work so well? Lower settling velocity. So here's a bar chart in front of you showing settling velocity in feet per minute on the left and a variety of proppants on the bottom. From left to right, you see the highest one, 3050 sand. Comparable to our 3050 Carboair, 40% reduction. In the middle is probably the most common proppant used in the US right now is the 4070 mesh. As you can see, Carboair, 40% less. What we're trying to achieve is a proppant that has conductivity and strength that approaches 100 mesh sand in the settling velocity. So now let's talk about our way of thinking mass versus volume. Same mass, pounds, means increased volume with Carboair. What you have in front of you are 3 vials with the same mass. What does that mean? That means 25 to 30% increase proppant volume and or coverage. So excuse me. Now we look at same volume, cubic feet, decreased mass. So the same cubic feet will result in less mass, but the same frac geometry. Ultimately, you get a 30% reduction in water consumption, flow back, horsepower, chemicals, time on location. If you think of this as a single vertical well, it's probably not that significant, but when you look at it in a horizontal case, times 40, times 50, times 60 stages, that 30% adds up pretty quick. Now let's look at a visual of what we've been talking about. So here's a Frac Pro output, generic output frac model. Now we're talking about mass, 100,000 pounds each. On the left, you see your sand frac, and on the right, the Carboair frac. Here it's obvious your 25 to 30% contact area increase. We've almost filled the whole fracture with Carboair. Increased contact area equals increased productivity. So how do we do this real time? Actual simulations. So Carbo approached a third-party company to build a slot flow test machine model. Here's a cartoon of what the model looks like. 20 foot in length, 4 foot in height. We have a bypass outlet at the top. We have a simulated perforation on the left. We wanted to obviously test Carboair with regular white sand. Doing that, we realized we have this facility. We might as well do quite a few more tests while we're here. So the conditions were all the same for each, all utilizing fresh water, a 10.5 gallon per minute slurry rate, and a 2 pound per gallon slurry concentration. So let's show a video on how the slot flow test works. On the top, you have Carboair 4070, the bottom white sand 4070. Notice the 100% volume. These are going to be the same identical frac, same cubic footage. Notice how light the Carboair looks in the fluid. The sand is already duning and rolling towards the bottom. The Carboair is floating across towards the back of the vessel. Remember, this is a 20-foot vessel. This video is sped up a tiny bit to illustrate what we're talking about, but as you can see, the sand has continued to dune and roll downhill where the air continues to float over the top. Remember, this is the same cubic footage, should be the same frac. Remember the 30% reduction in water, reduction in chemicals that I mentioned? Now, your Carboair frac is done. Meanwhile, your sand frac is continuing to pump. 30% more chemicals, 30% more water, horsepower, etc., more time on location. So think of this times 60 stages. Now that the fracs are completed, you see a visual of the frac dimensions. Remember the angular tendency of the sand? It packs tighter. Does not necessarily mean more contact area. Look at the Carboair. The thing you don't see is in the discharge of the water and the proppant that was discharged while this test was going, 0% sand and 3 to 5% Carboair floated out of this fracture. Here's an illustration of what you missed in your increased propped area. This is a coverage of what was done with Carboair versus white sand. Remember, same cubic footage, should be the same frac. Next, we're going to show you an example of an alternating stage frac that we did utilizing sand and air. These are as well, same cubic footage, same volume of sand, same volume of air. Started with sand, layering air, notice, all the way to the back of the vessel. Then we came over the top with sand, and then our final stage was Carboair. You can see the illustration is similar to the design that we achieved with 100% Carboair, and this time layering in sand. Remember, same cubic footage here. Now that we've seen this in action, what has it done in the field? So 33% increased productivity is what it's done. For those of you not familiar, this is the Eagle Ford Formation, a tight gas formation in South Texas. We had twin wells, same completion. Well A with the sand, 100 mesh, 4070 sand. Well B, identical, 100 mesh, 4070. They replaced 20% of the cubic foot sand, replaced 4070 with Carboair. On the right is a normalized PI chart, as you can see plotted over cumulative gas per stage. 33% increase utilizing a 20% tail end with Carboair. This well is approaching 2 years in production. Here's more examples of its success. So 2 more large unconventional basins in the U.S., one utilizing a tail end, the other actually taking advantage of the alternating stages, using two mesh sizes of Carboair, 4070 and 3050. Remember the 30% reduction in water? That was the driver for this client in the Marcellus. In northeast U.S., they wanted a reduction in water. Water is extremely expensive to haul in and haul away. So what did they do? They designed their frac 50% tail in with Carboair, ultimately achieving less chemicals, less water usage, less time on location. These 2-week fracs, I think on the average, we're getting 1 to 1.5 days reduction in pump time. Here's another oil field example, gravel pack applications. So what are the problems you're facing? Poor coverage using conventional proppant, high viscous fluids, higher bottom hole circulating pressures resulting in gravel packs growing into the fracture, bridging off, ultimately shutting down and not achieving your gravel pack to success. So what does Carboair do to this? Obviously improve coverage, utilizing a thinner fluid, a less viscous fluid, lowering pump rates and pressures to achieve 100% pack with little impact to the formation around it. We've done this around the world, North Sea, Trinidad, Egypt, even South Texas here in the U.S. And with 40 plus gravel packs under our belt, we can say we have 100% success rates. Let's review this case study I mentioned in the beginning. This one was tricky. Large, significant washouts, lateral length, toe up horizontal wellbore. When the engineer ran the simulations, it showed excessive pump rates and pressures to try and achieve this gravel pack. Most of the simulations failed. So they contacted Carbo. What can we use? How can we take advantage of Carboair, the 2.0 specific gravity proppant? Well, we gave them the data on it. They ran the simulations. Simulations came back, showed a successful alpha beta wave completion, obviously lower pump rates, lower pressures, and a lower viscous fluid. And after 27 hours of continuous circulating, the end result was a full annular pack with no bridging. So what does all this mean? This means this is a proven technology. We've implemented it in all the hydraulic fracture treatments, gravel packs. We've done this around the world, major shale plays, onshore and offshore. So you might ask, well, who's doing all this work? Well, we have super majors all the way down to the small private equity firms that are trying to take advantage of this technology and increase their productivity and their contact area. So now in conclusion, operators had a problem. They needed improved proppant transport. We delivered 2.0 specific gravity Carboair, 30% lower settling rate, 40% increase in volume, contact area, deployed across the U.S. in all major unconventional plays and across the world in high risk and highly successful gravel packs. Please visit our website at carboceramics.com. The additional slot blow videos are there, as well as additional information on Carboair. Now we're going to turn to questions. My contact information is on the bottom. If we do not get to your question, we will follow up, and please reach out to me directly for anything further on Carboair. Thank you for your attention, and thank you for tuning in. Here's Brian.
Lee, thank you for the presentation. I'd like to thank everybody else for your attention. At Carbo, we do provide engineering support for all of our products, including Carboair. We do like to be involved before, during, and after the fracture treatment. And we like to do that in order to help with the application of technology and also to understand the production results. Therefore, at Carbo, we would like to assist in the design of a fracture treatment incorporating Carboair. So now for a few questions. Shannon's compiled a few of them for us. So let's see, the first question here will be, is there any fluid compatibility problems with Carboair?
Good question. We didn't talk much about fluids. No, we have not seen any compatibility issues. We've used in slickwater environment, cross-link, linear gel, highly weighted brines, as well as acid treatments. Thanks. Good question.
Another question is why horizontal well gravel packs? Or I guess I would add to that, Lee, and ask what's the difference between a gravel pack with sand versus Carboair?
So Carboair in a gravel pack, like we discussed, will get you the extended reach that you need. It will get you the full coverage. Versus sand, now that's a reservoir issue as fines incoming, but ultimately Carboair is the answer for some of these difficult gravel packs.
We'll do one final question. Here's one on contact area. You have used the phrase contact area several times. What does that mean?
Another good one. So contact area we refer to as fracture length. and our fracture height, sometimes width. Some clients are concerned with length, while others are concerned with height. So we didn't want to alienate one or the other. So increased contact area is definitely an improvement, whether it's length or height inside your fracture.
That's all the time we have. As Lee mentioned earlier, any questions additional questions that were submitted, we will answer those offline. I'd like to thank you again for your attention and remind you that this webinar was recorded. So if you had problems with the audio or video, you can see that later. And this is the first in a series of technology webinars from Carbo, so there'll be additional ones coming forward. And as Lee mentioned, there is additional information about Carboair and other technologies on our website, including the videos of the slot flow test. Feel free to reach out to Lee or myself. I'd like to thank you again and say goodbye.